Hello my friends, welcome again to my video channel. Today we will continue our work on the Drake TR7. At the end of the last part of part 2 we have seen that we have obviously a problem in the RX path. We have a very low sensitivity for the calibrator and for an external signal. So first we will focus on the receive path. I've observed that the sensitivity is very low with the calibrator and also with an external signal fed in from the antenna connector. So I will look at a point where both signals come together and check there. And this common point is here in the high pass. Here we have the calibrator signal and here we have the antenna signal which comes from the right side, from the high pass filter. It's connected here together and then it goes to the RF up converter. It's a RX path in this direction. The one of the pre-owners, maybe the last owner, made a note regarding these diodes. I will check the voltage drop across them. When I switch on the calibrator, we will have here approximately 10 volt and then we should have a voltage drop of approximately 0.6 volt or so over these two diodes. I will check it and see what happens. Calibrator is switched on. This is the input signal 9.9 volt. It's a switch plus 10 for the calibrator, that's okay. Behind the first diode there's a resistor 5.7 volt. This is this resistor, this 1 kilo ohm resistor. This makes sense because we have here 1 kilo ohm and the other kilo ohm is here to ground. So we have 10 volt, a little bit more than 5 volt because we have the voltage drop of two diodes, 5.6, 5.8 or 5.9 is okay. We can measure it. This voltage drop here 5.6. Sorry, this is 5.5. It's behind the first diode. Same voltage, and here we have 4.2. That's behind the second diode. So I assume that these diodes here, these two diodes, are obviously okay, and I can't imagine any fault which would cause a loss of sensitivity for both. If one of these diodes is interrupted, then we have a weaker calibrator signal, but the receive signal goes through. It is not damped. And if one of the diodes is shorted inside, then you have a calibrator signal and maybe the receive signal would be attenuated. But we have both weak, so I will do the next check into the direction of the up converter and remove the plugged coax connector. So my next assumption is that we have a problem not here in the switching. I don't go to the switching here because here is only affected the RX signal which comes in from the antenna and over the relay. This wouldn't affect the calibrator signal, but the calibrator is also weak, so the problem must be behind this point. And behind this point we have this shielded cable. I unplug it, and this cable here is the input to the so-called up converter, or it's the output of the down converter. The first IF is 48.05 megahertz. It's 48 megahertz. First IF is a rather high first frequency. There's a small roofing filter, okay, 10 kilohertz or so, not small regarding to the data we have today, but it is small, and I will infeed my RX signal here and see whether we have a higher sensitivity. We have here the output of my signal generator. It is set to 3.8 megahertz and 50 microvolts. This should be an S9 signal. I connect it to here and I go to 3.9 The S meter does not move and the signal sounds rather weak. I go down some decibels. You can hear it, it's a 3 microvolt signal. There is something wrong. In this direction here, I assume it's the up converter or a later stage in the RF, in the RX path. And now the ugly part of the story. I have to remove again this shield, of course this jumper board, the shield here, which I had off during cleaning the contacts. I installed it, thought the problem is solved. The problem was not solved. I have to unmount this and this, and then can get out the up converter board. By the way, this up converter is also the down converter. In case of transmit, the signal comes out here via this cable into this part here, into the high pass filter, and then it's fed to the PA, and then it comes to the low pass filter, which is here. The PA is here on the right side. So this is RX and TX. We have a DEF RX, maybe we also have a DEF TX. Don't check it, I have to open it without discussion. The up converter board is out, and to check it I use my extender boards I have. You cannot work on such a transceiver without extender boards. And to avoid a short circuit I use this experimental board. It is isolated on both sides. I feed it in, and with this I can prevent any shorts. Now it is plugged in. I hope this wire is not too short, but it's not necessary to connect it. I will connect my signal generator here, and the other board, jumper board, I should have it installed before, and there's a screw which makes trouble. Can make a short. I screw it down. Oh no, I have to shift it a little bit. Luckily these extender boards are long enough to shift them. But again, I have to look for shorts. I don't like this. I will make it better. It works again, but again we have a weak signal, and now I have to check why. The signal was weak because I had only 3 microvolt. I increased it to 50 microvolt, and what I see, we have S9. Don't believe? You can see. We have an S9 signal. Is there a short or another problem? This is a signal 0.3 microvolt. We can hear it in SSB bandwidth. CW 500 Hertz filter. Where is the problem? The problem the cable, the shielded cable, that it is broken or makes a short or so. Here's a second mixer. There are some solder connections, but I assume it's original from the factory. This is for serial 4000 and above. Okay, what do we have here? $4,202. So it's the right board. Is there a short when it is in the chamber? No, there is no pin, which is too long. I really don't understand it in the moment. Oh, I love this. The board is in the box again. Jumper board, the connector, the wire is connected to the plug. When I switch on the calibrator, signal S8, S9. And when I go to the odd, it's 9 plus 10, 15 dB. I think that's okay. And the even one is a little bit smaller, but it works. What's going on? With the cable? No. Just plugged in. I don't know in the moment where the problem is. What's the problem is? I checked all contacts optically, also solder connections of the plugs. It's a mystery. In the moment it's a mystery. To make the check complete, I connected my signal generator to the antenna input on the rear side, and I have also the same signal strength, S7 or so. Should be a little bit more, should be S9, but I think that's not the topic in the moment. I have full sensitivity now from here over this wiring to the up converter and the other stages. In the moment I really don't understand where the problem is. We have here the problem that with all PCBs, that the distance between the pins, the wires and the shielding within this compartment here is rather small. There's a distance holder, a spacer, which prevents the PCB to come too close to this part here. But on this side there is no spacer or distance holder. So this means that this can have contact. I will check the length of all of these pins here. There are some weak points where the screws are, the metal is bended inside like a half pipe or so. This is not so good. Can make a critical contact here on these pins, or here even with these pins, or no contact, or maybe a capacitive coupling to ground, which could destroy the behavior. So I will take this PCB completely out and check all the lengths here of these wires, shorten them and reinsert it. And another problem is sometimes that especially in this case, this PCB is not fed into the right position. And on this side here, with a rail or so, on this side we have here a rail, so the PCB is held, but here not. That means it can be shifted in this way. And this can also cause problems in the contacts when the pins are not centered. So I will check all these possibilities and then reinsert it and check it. And of course the problem is that some problems with the reception cannot only be caused by this part here, by the up converter. We have a second mixer which is here. The output of this is fed to the second mixer. Then we have the filters. We have here the passband tuning, and BFOs, oscillators, and here we have the demodulator. In all these stages there can be a problem, of course. All would affect the sensitivity and the S meter. So if there's a problem, maybe the problem is anywhere else. Next step is when I have it is working, I will do a first transmit check. Maybe the problem is better to be identified with a transmit signal, not in receive mode. I will see, but first I will check here all the wires. Maybe you have seen in the last sequence that there was a solder connection which was not soldered. This pin here, I resoldered it, but it is not electrically relevant because it's only the shielding of this case. It is connected, but this is no connection to ground. No other wires are connected here, so it's only a mechanical issue, not more. But I resoldered it. No problem. Here we have the VCO board. This red distance holder was missing. It was laying in the compartment. It was lost, so there is a danger that the PCB moves towards the metal shield of the compartment, and this could also cause shorts to ground. I have shortened some of the wires. There's also the screw in this range. I shortened the wires, so maybe we had the problem not in the up converter but in the VCO. Could also cause a bad reception when there's an attenuation of the VCO signal. Well, I wait until this glue is dried out, hardened out, and I will then reinstall it. Additionally, we should check the bottom side of the main board. It's here, whether we can see any problems in the contacts, but the contacts here are all, for the PCB contacts, they are all shiny. There are no halos around the pins. Nothing is broken or corroded or so. All wires are good connected, so I don't think that there's a problem. The other side, the pins itself, I cleaned, as we have seen. These tantalum caps here are okay. I checked them with a capacitance meter. They are also okay, and if they are faulty, we would see it, but we wouldn't have a varying sensitivity in such a way as we have seen. By the way, here is the famous point, which is sometimes interrupted to get the TR7 transmitting on all bands and all frequencies. This is a TX-enable disable wire. It's done by some guys. They just interrupted. We see here the sign of a knife or so. So it looks like it was interrupted. Or it's a sign of a Dremel tool or so, don't know. And then later someone resoldered it again and improved it. It's not a good idea, because the TR7, when it's getting old, has a tendency that the PLL unlocks, and when the PLL is not locked, then via this connection here the transmitter is disabled. This is very important, otherwise we would send transmit outside the amateur radio bands, which is not which is forbidden in all countries, as I know. So this is a necessary connection here. And just to interrupt it, to have transmission on all frequencies, is a bad idea. A better idea is to use the auxiliary 7 and to add several bands with a diode matrix, as it is stated in the manual of the auxiliary 7. There's also another possibility I will show you. An option, if you don't have the AUX7, the original AUX7, which is hard to find, and if you find it, it's rather expensive, is such a simple PCB here. It's a replacement. It's pin compatible. There are the diodes in place for the new amateur radio bands, 10 MHz, 18 and 24.5, and also for the very low bands, 1 MHz, 0.5 and 0 MHz. So we can start here from 0 MHz on. Whether it makes sense is another topic. 7 and 8 is not equipped. So this can be used as a replacement for the auxiliary 7, but if this is also very hard to find. But maybe you can do it by your own. There are some descriptions in the net where you can find it. Another solution for this topic is, as I have seen in a comment in the last video, that there is maybe a modification in the TR7 with a new ROM or PROM, which covers also the new bands, not only the old ones, but also the new bands. I will come back later to the topics when I install the TR7 and check it. But in general, this is okay here. I don't see any reasons to do here any soldering. The shield is in place now, jumper board also, cable is plugged. This is an external 3.8 MHz signal, same as before. Estimated deflection, as I see, is a little bit less than before. Maybe the capacitive influence of the shield is negative, so it has to be realigned. I will do a complete realignment, but now I cannot see any signs of problems. Not in the second mixer. Filter board, cable of the filter board. Nothing. So I'm quite sure the problem is solved, whatever it has been. Maybe there was a contact here on the board of some of the pins to the screws. Could be an explanation. I shortened them all. And now, as I see, it's okay. Hopefully. I will see what happens when I do the first transmit tests. The shield is in place now, jumper board also, cable is plugged. This is an external 3.8 MHz signal, same as before. Estimated deflection, as I see, is a little bit less than before. Maybe the capacitive influence of the shield is negative, so it has to be realigned. I will do a complete realignment, but now I cannot see any signs of problems. Not in the second mixer. Filter board, cable of the filter board. Nothing. So I'm quite sure the problem is solved, whatever it has been. Maybe there was a contact here on the board of some of the pins to the screws. Could be an explanation. I shortened them all. And now, as I see, it's okay. Hopefully. I will see what happens when I do the first transmit tests. So I'll do the first transmit check, and it looks good. I connected a big dummy load, 600 watts or so, homemade power supply. I don't use an external watt meter, I rely on the internal, and I see the current which is drawn in the mode CW. When I go to the 80 meter bands, 3.8 MHz, and you see 100 watts and more, the drawn current is 20 amps. I think that's okay. In the 10 meter band, the output power is a little bit less, 60, 70, okay, I would say 80 watts. And now the ALC reacts in the range of 80 watts. But it's also a good value for the 10 meter band. Many TR7s have problems in the 10 meter band. 15 meter, okay, 100 watts. That's good. Let's check SSB. SSB is aligned, not perfect. The pots here have to be realigned, but I increase the volume. Test. Okay, it works. By the way, it's a good moment to check the Vox. Checking the Vox, this knob is out, so we have PTT and Vox operation. When I depress this knob, we have only PTT, but it is out. Got no reaction. Anti-Vox is counterclockwise, delay to the center. Okay, Vox doesn't operate. Maybe it's a question of the microphone, because some microphones have a wiring internal that when the PTT is not depressed, the internal microphone, the dynamic movement is disconnected. I had the problem with another transceiver some months ago. Maybe that's a problem, but it's not the main topic in the moment. Important is that we have output. And now we are at the end of part 3 about the series of the TR7. We made good progress. The receive path operates. I hope it's a stable operation and that we found the culprits. I didn't really identify the problem precise, but I assume it was a contact problem. Maybe wrong plugged in boards, or some wires were too long and they touched the ground or so. The transmit path also seems to work in general. So what has to be done? I have to check the Vox operation. Maybe have to rebuild this circuit here, which we have here now, or I have to check it. Maybe a wire is broken or so, or I have to go back to the original situation. It will be a little bit difficult. I don't have the original potentiometer here. And of course, alignment is necessary. A complete new alignment has to be done. New topics, but I think we are on a good way. Stay healthy, stay tuned. See you on this channel.